All right, for this week's check-in, you're supposed to take a separate sheet of paper and sketch a graph. That's all you needed to do. You didn't have to write a polynomial or anything. All you needed to do was sketch the graph of a polynomial that would have degree 5 with a negative leading coefficient and 3 zeros with odd multiplicity. So my thinking for this is that if I'm degree 5, I notice that that is of odd degree. So the end behavior for an odd degreed polynomial is either this way or the other way. And since we have a negative leading coefficient, we know that it's going to fall like that. So again, for degrees, when you're looking at it being odd or even, if it's odd, I'm thinking more it looks like our x cubed graph, which if you think about it, if you plug in a 1, you get 1, -1, you get -1, and so it's kind of growing in that way. When you're thinking about an even function, I think about the most basic, which is x squared, which is going to be growing in this way. And so if you put a negative in front of x squared, it flips it. So again, that's how you could think about the end behavior for an even degreed polynomial with a negative coefficient. Similar for the x cubed, if you stick a negative on there, it just flip-flops because it's a reflection over the x-axis. So I know right now, because of my degree of 5 and my leading coefficient being negative, I have end behavior like that. So I can start by just putting that onto my graph so I know those are my endings. Then it says I have 3 zeros, and I guess I should have said real zeros with odd multiplicity, but 3 zeros here should mean to you that you're touching the x-axis 3 times, only 3 times, not more than 3, just 3 times. And then the odd multiplicity means that we go through the graph. Remember, if it was even multiplicity, it bounces. So again, similar to the functions that we already know about, these parent functions. X squared bounces. It has a 0 at 0, 0, and it bounces. X cubed has a 0 at 0, 0 also, but it doesn't bounce, it goes through. So those are ways to help you remember that odd and that even. So to finish my sketch, I just want to make sure I don't do any bouncing. So I'm going to go through that 0. I'm going to come up, go through that 0. You can have turns, but notice I'm going through the axis and connect those together. So there's an example of one polynomial function that has those characteristics. So hope that's helpful.